horizontal massless rod. We have taken the massless rod. We could have taken it mass also. Or let's consider even the mass of the rod also. This is a uniform mass rod, and let's take it as 10 meter and 20 kg. Let's consider it. This is a pin jointed over here, so that's why it can rotate in this direction. This rod is tied over here and fixed over here. Angle is 30 degree. We have to find what is the tension in the string and reaction forces of the pin, as we did earlier. So obviously, if this is 20 kg mass rod and it is uniformly distributed, this 10 meter, so the force of this is going to be 200 Newton. We can replace by 200, that is 20 into G. G we are taking for convenience of calculations as 10 meter per second square only. So 20 into 10, that is makes 200 Newton. So this is 5 meter and this is 5 meter. We have said that it is in the middle of this thing because this is uniformly mass rod. Mass distribution is uniform. So the whole weight will be acting at the center of gravity, that is in the middle only. So now, once again, the confusion, maximum confusion is over here, right? So what we do is that this force and this force, 200 Newton and 100 Newton will try to rotate in this direction. We are taking torque about O is equal to 0. Net torque about O is equal to 0. This rod is not rotating about this axis O. So torque of this force about this axis, that is 200 into 5 plus 100 into 5 plus 5, 10 is equal to, now this is T. So now T is in this direction. So as we said earlier, it may be easier to break this T into two components. One is, we say T cos 30 degree. So this angle is 30 degree, so that there is no confusion. So that's why I removed it. So this is T cos 30. So this is T sin 30. Torque of T cos 30 about this axis is going to be equal to 0 because torque is force into perpendicular line of force and acceleration, and this force is passing through the line of force only. So torque of this force about this axis is equal to 0. This force and this force, they are trying to rotate the body about this axis, whereas T sin 30 will try to rotate this rod about this axis. This rod is not moving neither along the clockwise direction or along the anti-clockwise direction. So clockwise movements is equal to anti-clockwise movements. So this 200 into 5 plus 100 into this thing, that is clockwise movements, is being balanced by anti-clockwise movements, that is T sin 30 degree force into perpendicular distance between line of force and acceleration. This line of force, acceleration, so perpendicular distance is this, into 10. So this comes out 200 into 5, that is, we say 1000. 100 plus 10, that is once again 1000, is equal to T sin 30, that is T into 1 by 2 into 10. So this comes out to be 2000 into 2 upon 10 is equal to T. So T comes out to be, that is 400 Newton. So tension over there in the string is going to be 400 Newton. Now comes, what is the pin reaction, or what is the forces which are being experienced by this rod over here. So once again, we draw the force diagram of this rod and we find out, that is, what are the forces which are acting over here. So this way is T sin 30, T we have calculated, that is T sin 30 is obviously, T sin 30 is half, so this is 200 Newton only. And this way is T cos theta, T cos 30. So T is how much? It is 400 into cos 30 is root 3 by 2. So this makes 200 root 3 Newton. 200 root 3 Newton. And one force is over here downwards, that is 100 Newton. And one force is over here, that is 200 Newton. Over here we can say, let's say the forces which are acting over there, we see that is 200 Newton, 100 Newton, this thing. Let's say one force is acting in this direction and one force is experienced in this direction, right? The confusion was here, what sort of force is acting over here? This can be broken into its components. One is Fx, the other is Fy. So we have broken this force, any reaction over there, it could be this direction, any direction. But that can always be resolved along the x-axis and along y-axis. We have taken the components. Now, this rod is stationary. This rod is stationary. This is not moving along x-axis and along y-axis. So it means that net force along x-axis, net force along x-axis is equal to 0. It means this Fx, this side force should be equal to this side force. So it is 200 into root 3. Net force along y-axis, that should also be equal to 0 because this rod is not moving on the y-axis also. So it means Fy plus 200 upward forces, that should be equal to downward forces, that is 200 plus 100. So from here you can find Fy and Fx is known. Once Fy and Fx is known, we can find this resultant force, and this resultant force is going to be under root of Fy square plus Fx square. And what is this angle? That is tan theta is going to be, this is Fy, so this is also Fy. So it is going to be Fy by Fx. You can find the angle also, you can find the magnitude also. Once that is known, the pin reaction, that is pin is applying a force in this direction, so pin will experience a force in the opposite direction, the same magnitude and the direction in the opposite direction. To have reaction, there is equal and opposite reaction. So from there you can find the forces or the pin reaction.